Good morning, students. So you are welcome once again back to the physics class. We could not have a lecture which was scheduled yesterday, so I'll cover the things up today. Okay. Now what we are going to discuss over here in this particular lecture is going to be extremely important from the point of view of solving some circuit diagrams and getting to know the battery EMF, terminal voltage and other terms. Okay. So let us begin the lecture first with the concept of EMF and terminal voltage. Okay. Now EMF, the word itself you must have heard. It is the battery voltage or the EMF of the cell, electromotive force of the cell. It is represented with an E looking letter, but not exactly E. It is known as epsilon. Okay, so you will make this letter as this, and then we obviously have the terminal voltage represented with a capital V. Okay, now what is the difference between these two things? What is it exactly going to differentiate between EMF and terminal voltage? All that we are going to understand now by keeping in mind this particular simple circuit. Okay, so let us first have a look at the circuit. Now what does this simple circuit consist of? It consists of a battery. As you can see over here, there are two cells arranged. Okay, so it's in fact a battery, and its EMF is represented, or the battery voltage you can say, it is represented with an epsilon. Okay, so you have this as the EMF of the cell, or it is also known as the overall battery voltage. Okay, the total voltage that the battery can supply. Okay, now where is this voltage going to be used up? Okay, so this battery voltage is actually going to be used up, number one, across the external resistance. So as you can see, this shaded portion over here that I have enclosed in a shaded square, this portion is actually denoting the battery. Okay, this internal resistance R is known as the internal resistance of the cell. So you can simply write this down as the internal resistance of the cell, okay, or the battery. Okay, because you always have some resistance or the other acting in the external circuit also, as well as in the internally in the battery. Okay, so this R, although it has been shown separately in the circuit diagram, but you can assume that this internal resistance is that of the battery itself. Okay, so that is why this whole portion has been put under this dotted square. Okay, now we were talking about the overall battery voltage. Okay, the voltage that the battery is supplying. Okay, so that voltage is going to be used up here, number one, in the external resistance as well as across the internal resistance of the battery. Okay, now it is easier to say all this, but to understand we have to have a look at this particular equation. Now you see, this over here is the overall battery voltage. Okay, and capital V will denote the voltage drop across the external resistance. Okay, as you can see, V over here I have written potential drop. So potential drop is also known as voltage drop. Okay, across the external resistance. You see, external resistance. So external resistance in this circuit over here is R. Okay, so whenever there is some current passing, as you can see in the diagram, suppose I, capital I is the current that is drawn, so this same I is going to travel through this R also, and then it is going to travel through this internal resistance also. Okay, so whenever current passes through a resistance, what is resistance? Resistance, as I have already told you, it is an obstruction in the flow of current. Okay, so whenever current passes through any resistance, there is a voltage drop, or there is a usage of some of the voltage portion that the battery is providing. Okay, and how will you determine that voltage drop? Okay, so suppose you want to measure the voltage drop across this external resistance R. So what you are going to do is, you are going to simply connect a voltmeter. Okay, you are going to connect a voltmeter across this resistance. Across means across the two ends of the resistor. Okay, so you have put a voltmeter. This voltmeter is going to show you some reading. How is this voltmeter going to give you the reading? By using the simple formula V is equal to IR. I is obviously the current that is going to pass through this resistor, and R is the value of the resistor itself. Okay, so this formula, as you can see, it is representing the Ohm's law. Okay, so using this formula, this voltmeter is going to measure the voltage drop that is taking place across this resistance, which is the external resistance. Okay, so now I'm going to remove this because this was not originally the part of the circuit. So now, having understood the capital V, let us go down to small v. Small v also is the potential drop only, or the voltage drop only, but not across the external resistance, but across the internal resistance of the battery. Okay, so this small v will also have the same formula IR. The only difference is here the R will not be the external R, but it will be the internal resistance R, small r of the battery. That is why, because of this small r, this voltage is also represented with a small letter v. See, essentially this and this, both these are representing voltage drops. Okay, both these are representing what? They are representing voltage drops, or voltage or potential drops also, you can say. Okay, both of them are Ohm's laws. Okay, they both represent Ohm's laws. The only difference is that this voltage drop and this voltage drop is happening across different resistances. This voltage drop is in the external circuit or across the external resistance, whereas this voltage V, small v, is the potential drop across the internal resistance of the battery. It is the sum of these two drops that is making up the overall battery voltage. Okay, so one last thing that you have to remember before we move on to the numerical portion is both these voltage drops, both these are representing voltage drops, one across the external resistance, one across the internal resistance. The one across the external resistance, this is capital V, is also known as the terminal voltage. Okay, so this is also known as the terminal voltage. In the same equation, this equation can also be represented like this. If you take this V to the other side, it will be epsilon minus V. Okay, so the same formula can be represented in another way. So this V, capital V, is known as what is terminal voltage. Okay, terminal voltage. So how will you calculate terminal voltage? By subtracting the internal voltage drop from the battery EMF. Okay, so I hope this part has been understood properly, because now we are going to move to some numerical portions. Okay. Okay, so now let us have a look at question number 1. Calculate the current drawn from the battery and the currents flowing in the individual branches. Okay, now let us understand what is this current which is drawn from the battery and what are these individual branch currents. Okay, if you see in this particular, obviously this is the circuit diagram that is a part of this question. So for solution we need to understand the circuit diagram first. So this circuit diagram, obviously, as you can see, it has a battery EMF of 6 volts. Okay, so the net battery voltage that this battery can supply is 6 volts. Okay, now there are two resistances, as you can see. You can call this to be R1, okay, and you can call this to be R2. Okay, these two resistances, as you can see, they are present in the parallel combination. Okay, so the first thing that we will calculate is the R total of the circuit, because you can see this battery does not have any internal resistance. Practically it is not possible, but for this question they have not given you any small r value. Small r value has not been given, so we are not going to take any small r value. Okay, so the only resistances are these two resistances, and they are external resistances in parallel combination. So we are going to use the formula R1 R2 upon R1 plus R2. So very quickly, 2 into 3 divided by 2 plus 3. So this is going to give you what? R total value of 6 upon 5 ohms. Okay, we are not going to calculate that into decimals because it is going to get cancelled. So this is the R total of the circuit. Why are we calculating R total of the circuit? Because if you remember, V is equal to IR. If we apply this formula for the overall circuit, then this is the battery voltage that we can use, 6 volts, equal to I is the main current that is going to flow. So now I can immediately label the diagram with this I, and it is obviously going to come out from the positive terminal. The big bar is the positive terminal and the small bar is the negative terminal of the battery. So from plus, I has come out. Now this I is this current drawn from the battery. Okay. So the first thing first, the question had asked you current drawn from the battery, which is the main current or the total current that is drawn. So for calculating the total current, we must always calculate the total resistance also, which we have already calculated. Okay. So this formula V is equal to IR. For the overall circuit, for the whole circuit, it will be interpreted in this particular way. The voltage will be the battery voltage, 6 volts. I is the total I which is drawn, multiplied by the R total. R total is 6 upon 5 ohms. Okay. So in order to calculate I, very simple, this 6 and 6 gets cancelled, 5 goes that side. So you have 5 ampere as the main current or the total current drawn from the battery. Okay, so you can write over here current drawn from the battery. Okay, so that this particular setup of resistances and the battery is drawing how much current? 5 amperes from the cell. Now let us see how it moves ahead. It comes over here. Now the moment it reaches over here, this 5 ampere current has two paths to follow. Okay, it can go this way also, it can go this way also. Okay, so there are two paths available. Some current will flow in the first arm, some current will go into the second arm. Okay, now let me tell you before moving ahead, the moment the current distributes, this 5 ampere gets distributed. Now how much goes into this and how much goes into this, we are going to deal with that later. Please understand that the moment they come out over here and reach this particular point, again they are going to come out together as 5 amperes, which is the main current in the circuit, and this is how the circuit gets completed. Okay, so now the only part that is remaining is to find out the currents flowing in the individual branches, which is this branch and this branch, I1 and I2. Now one more thing, before calculating I1 and I2, let me tell you that if these two resistances would have been of same value, suppose they would have been of 2 ohms and 2 ohms, then immediately what you would do is you would half the current. So out of a total of 5 amperes, 2.5 would have gone here, 2.5 would have gone here. What is the condition for that? Condition is these two resistances have to be equal. Okay, regardless of the value, it can be 3, 3, it can be 2, 2, it can be 1, 1. Okay, as long as these resistances in the parallel combination they are same, the current gets halved. That means half goes into one arm, half goes into another arm. Okay, but here as you can see the resistance values are not same. So please note, for calculating I1, the formula is, for calculating I1, which is the current flowing in R1 branch, you will not take R1 value, you will take R2 value at the top, divided by R1 plus R2, which is the total resistance, sum of these, multiplied by I total. Okay, so you can call this to be I total. I total is this I. Okay, so this is I total, as you can see. Okay, you can write here also I total. Okay, so for calculating I1, this is your formula. Similarly, for calculating I2, which is the current in the second branch, what will you do? Again use the same formula. Since when we calculated current in the R1 arm, did we take R1? No, we took R2 at the top. Similarly, when we want to calculate I2, which is the current in this arm, we will not take this resistor, we will take the other resistor, which is R1. Now why are we taking alternate resistances is because remember I and R, they are inversely related. More the R value, less is the current. less the R value, more is the current. Okay, so that is why in order to calculate current in a particular branch, you take the other resistance at the top, and obviously at the bottom you will always have R1 plus R2, which is the sum of them multiplied by again I total. Okay, so this is the I2 formula. Now those of you who have a little intelligence, you will automatically come to know that once we calculate I1 or I2, the other branch current need not be calculated by using the formula. You can simply subtract I1 from the total current to get I2. I'll show you what exactly I mean by this. Suppose I want to calculate I1, okay, which is this current. Okay, so let me use this formula. R2. R2 is what? It is 3 divided by R1 plus R2. So 3 plus 2 is going to give you 5 multiplied by I total. What is I total? 5. So 5 and 5 they get cancelled, and you get an I1 value of 3 amperes. Okay, so the current which is flowing in this branch now is 3 ampere. So do you now need to apply the same formula for I2 also? No. Immediately you know, since the total current was 5, 3 is going into this, so automatically the remaining 2 goes into this one. So I2 becomes 5 minus 3, so the remaining current is 2 amperes. Okay, now you see, this is the smart way of doing it, although you could have done it using the formula also. And you can see very easily I1 plus I2, 3 plus 2 is going to give you 5 back again. Okay, so this is the basic question that you must understand in order to solve such type of questions. We'll quickly move on to one more question. Okay, so let us quickly begin with the next question. In the circuit diagram, calculate there are 3 parts to this question, so the circuit diagram has to be understood first. Let us have a quick look. How many resistances? External resistances 3, 2 ohms, 4 ohms, and there is one resistance whose value we don't know, so it is given as R ohms. Okay, the second thing that you quickly notice is that these two resistances are in parallel combination, and the resultant of these two is in series with this 4 ohm resistance. Okay, the current flowing, the overall current flowing in the main branch is 0.25 amperes. Okay, the battery EMF is 2 volts, and the battery also has an internal resistance of 3 ohms. Because this 3 ohms value is written next to the battery voltage, so we will assume, or we will have to take it as the internal resistance of the cell. Okay, so you can immediately label this EMF of the battery is 2 volts, and the internal resistance of the battery is going to be 3 ohms. The main current, which is the current flowing in the main circuit, is 0.25 amperes. Okay, so what is being asked? Number 1, the potential drop across the 4 ohm resistor. Okay, where is the 4 ohm resistor? This is the 4 ohm resistor. We have to find the potential drop. That means the voltage drop. That means in lab, if we were asked the same thing, then we would have connected a voltmeter like this. Okay, we would have connected the voltmeter across the 4 ohm resistor if we want to get the potential drop across that 4 ohm resistor. So potential drop, which is always going to be represented with a V, potential drop across 4 ohms is nothing but voltage, so it is going to be represented by the formula IR. Again, V is equal to IR, Ohm's law. The only thing here to note is that this I will be the total I, which is already given. Why? Because if you see, now I am going to remove this voltmeter from here. Now you see, this is the main current that has started from the battery. When it reaches over here, obviously it is going to be split up. It is going to be distributed. Some goes in here, some goes in here. But the moment it comes out of here, again it will be combined, and it will be as 0.25 amperes. Okay, which is going to come down here and then back to the battery. Okay, so we want the voltage drop across this resistance of 4 ohms, so we will use the formula I total, which is 0.25 multiplied by R value. Now this R value is the 4 ohms value. Okay, because they only want, in the first part they only want the potential drop across 4 ohm resistor. So 4 multiplied by this, 4 5s are 20, 2, 4 2s are 8, 9, 10, 1, 2 places of decimal. So we are going to get this as 1 volts. Okay, so for the answer for the first part, which is potential drop across 4 ohm resistor, is 1 volt. Okay, so this is the calculation way. If you want to check this in the lab, then you don't have to calculate anything. Simply connect a voltmeter like I showed you, and that voltmeter will show you 1 volts. Okay, how is that voltmeter giving you 1 volt? By using the same method. Okay, so now quickly moving on to the second part, which is finding the value of capital R. Okay, capital R is this R that we have to find out. Okay, so that R is a part of the overall resistance. Okay, so let us first calculate the combination of these two R's. Okay, so these two are in parallel. So for parallel, we will write for parallel combination, we have R1 into R2 upon R1 plus R2. Okay, this is the formula for parallel that we know. So this becomes 2R upon R plus 2 ohms. Okay, ohms. So this portion is this portion. Okay, so we have calculated that value. Now this overall resistance, this value is in series with this 4 and this 3. Remember, we always have to add the internal resistance of the battery also. Simply add it. Whenever it is given in the question, we will add it. So we will write R total will be this R that we have just calculated for this part plus this 4 because it is in series, and plus the internal resistance of the battery, which is 3. Okay, so very quickly let us calculate this. This is going to be 2R upon R plus 2 plus 4 and 3 is 7. So if you want to have a common value, let us calculate. We'll take the LCM. LCM will be R plus 2. So this becomes 2R plus, so this becomes 7 into R plus 2. All this calculation, I hope you will be able to do that. 2R plus, the moment 7 goes inside, so you have 7R plus 7 2s are 14 upon R plus 2. Okay, 7R plus 2R will give you 9R plus 14 upon R plus 2. Please note that this is the R total. That means the overall resistance of the circuit. Why did we calculate this total R? Is because, please note, we have to make use of this total R to find out this R, because the second part says value of R. So we will apply that Ohm's law again. V total is equal to I total multiplied by R total. Please note that this formula is again simply Ohm's law. V is equal to I R. Okay, the only difference is here we have to take the battery voltage, which is 2 volts, equal to I total. I total is 0.25 multiplied by R total we have just calculated. So this becomes 9R plus 14 upon R plus 2. Okay, this equation can be used to solve for R value. Okay, now I'll just show you, I'll erase this and show you the exact calculation. Okay, so let's have a look back. I have erased some portion. The last line is written over here. So this 0.25 will go to that side. So you will have 2 upon 0.25. This calculation is up to you. You can do it whichever way you want. Only that the calculation has to be correct. Okay. So this portion, 2 places of decimal. So 2 zeros will be added up. This can be cancelled. 5 5s are 5 4s are 20, 0, then you have 5 8s are 40. Okay, so left hand side you are left with 8, and right hand side you have 9r plus 14 upon r plus 2. This r plus 2 can come here, so you will have 8 multiplied by r plus 2 equal to 9r plus 14. 8 goes inside, so you have 8r plus 16 is equal to 9r plus 14. Now we are nearing to the finding the value of r. 8r goes to that side, so you have 9r already was there, 8r goes to the other side, gets subtracted. Similarly, this 14 will come to the left side there was 16, 14 when it comes it gets subtracted, 16 minus 14 is 2 equal to 9r minus 8r is r. Okay, so you have r value as 2 ohms. So we have found out successfully the first part and the second part. Now, so the only thing now that is left is the calculation of the third part, which is the potential drop across the 2 ohm or 4 ohm resistor. Okay, so this part we are going to calculate now. Okay, so for calculating the third part, let us now move on to the third part, the potential drop across 2 ohm or R ohm. So now this R ohm is actually, we have just calculated in the second part, R value is also 2 ohms. Okay, so they want the potential drop across this particular portion. Okay, this portion or this portion, because you see they are basically the same things. This combination is parallel. Okay, so this particular combination is giving you an R value, R parallel. R parallel means this portion that I have circled, this will give you what? 2 and 2 in parallel is going to give you 1 ohms. Okay, you can use the formula R1 into R2 upon R1 plus R2. R parallel, this combination is 1 ohm. And what is the current that is flowing through this particular entire portion? The main current that is flowing is your 0.25 amperes. Okay, so for calculating the potential drop across 2 ohm or 4 ohm, what do? You simply apply the formula I into R parallel. Okay, reason why I am writing these words parallel and all these is so that you understand properly. In the actual solution you don't have to write parallel. Okay, so I value is 0.25, it was already given in the question, multiplied by this R parallel that you have calculated. Why are we using this R parallel? Because the question, the third part of the question is asking you the potential drop across 2 ohm or R ohms. R ohm is also this 2 ohms. Okay, so you have to find it across this. So the value is 1. 0.25 into 1 is going to give you 0.25 volts. Okay, so that is the answer to the third part. Now let us move on to the last question very quickly. Okay, so here is the last question. Find the ammeter reading in the circuit diagram given below. Okay, so here is the circuit diagram. You can see there are 1, 2, 3, 4, 5 resistances in all, R1 to R5. Okay, the values, as you can see, they have been given very quickly. The first thing that you see is there is a battery of 1.8 volts EMF. There is an ammeter that has been connected, and you have to find out the current flowing through this ammeter, because you have to find out the ammeter reading. Okay, so obviously this is the main current, because you see the battery positive terminal is this one, negative is this. So the main current that is drawn from the battery is this I. Here obviously it gets divided, but the moment it comes out again, it is going to be the total I. Okay, again here it is going to be divided into 3 parts, but then again it is going to come out as I total. So you don't have to worry about individual currents, you only have to calculate the I total which is flowing, and for I total you have to calculate R total. Okay, so quickly moving on to the solution part, we will calculate R total. Okay, so R1 and R2, they are in parallel. Okay, so this portion has to be calculated as parallel portion. This portion also has to be calculated separately as parallel portion. Once you get the values of these two parallel parts, you will add them up, because now they are in series. So R1 and R2 are in parallel, therefore R net here will become R1 into R2. So I am going to use the formula 10 into 40, this value is 40 upon 10 plus 40. Okay, so you are going to get 400 upon 50. 1 0 gets cancelled, 5 8s are 40. So for this particular parallel combination, resistance value is 8 ohms. Similarly, for this particular portion, you will have to use, so you write down for R3, R4, R5, they are also in parallel. So for this you have to, since these are three resistances, so you can't apply R1 into R2. Okay, so you will have to use the main formula, which is 1 upon R net, 1 upon R3 plus 1 upon R4 plus 1 upon R5. Okay, so very quickly, 1 upon 30, now I am putting the values, plus 1 upon 20 plus 1 upon 60. Okay, so what is the LCM going to be? The LCM for this is going to be 60. Okay, 30 2s are 60, so you have 2 plus 20 3s are 60, so you are going to have 3 plus 60 1s are 60, it is going to be 1. Okay, so now I am going to write down 1 upon R net is equal to 3 plus 2 5 and 1 6 upon 60, so this is going to be 1 upon 10. Okay, therefore now obviously we have to do the reciprocal, because we need to have R net. So doing the reciprocal, you have R net is equal to 10 ohms. Okay, here the value was 8 ohms. So for this portion it was 8 ohms, for this portion it has come out to be 10 ohms. Therefore R total, or you can also call this as R of the circuit, overall resistance. So this will be this 8 plus this 10, so it is going to give you 18 ohms. What is the battery voltage? Battery voltage is 1.8 volts. Therefore use that formula, V is equal to IR. Here V obviously is the total battery voltage, so the battery voltage is 1.8 equal to I total, we have to find out, multiplied by R total. R total we have just calculated, it is 18 ohms. Okay, so this 18 goes down, so I am doing the calculation here. I total, which is the current through the ammeter, because remember you have to calculate the ammeter reading. So this is 1.8 upon this 18 goes to the other side, it divides, so you are going to get 0.1 amperes. Okay, this is your final answer. Okay, I hope you have understood and enjoyed this particular lecture. I was a bit late in doing this. This is evening now, so but still for you it will be morning tomorrow. So when you go through this, I hope you understand this carefully and clearly and in the best possible way. After going through these 4 questions, you are free to solve the questions that are there in the book, some of them on your own. You have any problems, you can always ask. And in the next lecture, we'll be taking up the power portion. Okay, I square R, what is the power, electrical power that is used up whenever there is a current flowing through any resistance. Okay, so all that we are going to do in the next lecture. Thank you.